Welcome to the 11th of 13 SPSS video tutorials accompanying the first edition of the text, Introduction to Statistics for Social Sciences. We will be using IBM SPSS Statistics version 19 for this tutorial. If you are running a different version of the software, you may notice some slight differences. In this tutorial, we will show you how to conduct a one-way analysis of variance tests. For this tutorial, you will need the file Chapter 11 videotutorialdata.sav. This dataset consists of the two variables exercise and cholesterol. To provide some context for this example, suppose you want to determine if there was a difference in the mean level of LDL cholesterol across 3 different levels of exercise. Furthermore, the levels of exercise you are interested in comparing cholesterol levels for consist of those who do not exercise, which we will call the no weekly exercise group, those who exercise once a week, and those who exercise 3 times per week. The exercise variable in this dataset, which is called the factor in ANOVA terminology, is what we will use to represent those levels. So we have one factor called exercise that consists of 3 levels represented as 1 for no weekly exercise, 2 for exercise once per week, and 3 for exercise 3 times per week. Finally, imagine that after randomly selecting 15 respondents for each of the 3 groups, you record their LDL cholesterol level to create the dependent variable cholesterol. Now that we have set up our data, we are ready to conduct the one-way analysis of variance test. To get to the ANOVA test, we go to Analyze, Compare Means, and then select One-Way ANOVA. In the One-Way ANOVA window, we have a box for our dependent variable and a box for our factor. Since our dependent variable is cholesterol, we'll start by moving that into the dependent list box. Next, we'll move our variable exercise into the factor box. In an ANOVA test, there are a number of different types of additional analyses that can be done using the contrast and post hoc options. However, these are quite a bit more advanced than we can cover in this video and in the textbook. Later in this video, we will, however, show you where you can find the Levine's test and Tukey's HSD post hoc test. For now, though, we are going to press the Options button and request descriptive statistics and a means plot. We then click Continue and then OK to obtain the output. By default, SPSS will provide you with the ANOVA table. However, since we also requested descriptive statistics and a means plot, we are provided with them here. Looking at the descriptive statistics table, we can see that we are provided with information about the dependent variable LDL cholesterol level at each level of the factor. Right away, we can see that those who exercise 3 times per week have a lower cholesterol level than the other groups. In addition to the group level information, we are also given information for the grand mean. The next table in the output is the results of the ANOVA test. Here we can see that our F ratio is 96.129. Now if we were using an alpha value of 0.01, we would find, based on the table of critical values of F at 2 and 42 degrees of freedom, that the critical value would be slightly less than 5.18. Therefore, since our F value of 96.129 is greater than the critical value, we know that we would reject the null hypothesis of no difference. However, remember that SPSS also provides us with the p-value associated with our test statistic. So we could also compare our alpha value of 0.01 with the p-value of the test statistic, which in this case looks like it's less than 0.000. Since the p-value is less than our alpha value of 0.01, we reject the null hypothesis of no difference and conclude that there is evidence that at least one of the group means differs from the others. Remember that with an ANOVA test, we can only tell if at least one of the group means differs from the others. To determine which mean or means differ, you need to perform additional tests such as Tukey's HSD post hoc test. For our purposes, however, and consistent with most introductory textbooks, we will not cover the discussion of the additional tests here. Finally, in addition to the ANOVA table, we are provided with a plot of the mean of LDL cholesterol level for each group. This plot is sometimes useful for graphically representing the means provided in the descriptive statistics table. Although we won't cover the interpretation of the Levene's test or post hoc tests, it is worth pointing out where you can find these in SPSS. First, we need to go back to the ANOVA test window. To request the Levene's test, click the Options button, and then check the box next to the option called Homogeneity of Variance Test. This requests the Levene's test of homogeneity of variance. To request a post hoc test, such as Tukey's HSD, from the one-way ANOVA window, click the Post hoc button, and then check the box next to the option labeled Tukey. As you can see, other post hoc tests such as the Bonferroni test and the Scheffé test are also available in this window. This brings us to the end of the SPSS tutorial for Chapter 11. We hope that you have found this tutorial to be useful. In the next tutorial, we will look at how to use SPSS to conduct a bivariate correlation and regression analysis.